Hello everyone, welcome. This is your fifth chapter, the client server paradigm. See now, this is a testing a network service. So how to test a network service? So for that, first of all, you should use the 3-layered software architecture and modularize each layer on both the client and server sides. So the 3-layered application architecture, already you have seen that 3-layered architecture, that is a presentation layer, application layer and service layer. Presentation, application and service layer. So this is the 3-layered software architecture. You should apply this 3-layered software architecture to your application, okay, and modularize each layer on both the client and server sides, and use an incremental or stepwise approach in developing each module, starting with the stubs for each method. Compile and test a module each time after you put in additional details. So this is while building your software or application, first you should use an incremental or stepwise approach, okay. So while building application, you should use an incremental or stepwise application, starting with stub. Stub is a software module, and compile and test each module, and a module each time after you put in additional details, okay. So first you should compile and test each module, and develop the client first. It is sometimes useful to employ an echo server, which is known to be correct and which uses a compatible IPC mechanism to test the client independent of the server. Doing so allows you to develop the client independent of server. So here first you can employ, it is you should develop the client first. It is sometimes useful to employ an echo server, which is known to be correct. See, if you employ echo server, so the client sends request to server. So for each request, the server sends a reply, okay. So then you will come to know whether any mistake is, or whether any error is there in client or server, okay. And use diagnostic messages throughout each program to report the progress of the program during runtime. So you should include some diagnostic messages throughout each program to report the progress of program during runtime. So test the client server suite on one machine before running the program on separate machines. So the client will be run on one machine and server will be on other machine. But before you deploy these applications on separate machines, first you should the entire client server suite you should run it on a single machine, okay. You should run it on one machine before you deploy or before running the programs on separate machines. So this is how to test a network service. See next one, connection oriented and connectionless servers. The internet protocol echo is the basis for a well-known internet service. The echo protocol simply allows a client to send one text line to the server at a time, receiving an echo of each line from the server. So echo protocol simply allows a client to send one text line to server, and it receives an echo of each line from the server, okay. And connectionless echo client server. The echo client, it provides the user interface for prompting for the server information and then using a loop for the text lines to send to the echo server. So here echo clients sends lines or text lines to echo server. In return it gets reply or as from the server, okay. For each line it gets a echo or a reply from echo server. So the sending of the text string and receiving of echo in return is handled by a method get echo of a echo client server, okay. Echo client server is an application and get echo is an method The sending of the text string and receiving of echo in return is handled by a method getEcho. Echo server. In each iteration of the forever loop, the server reads a line from the socket and then writes the line back to the socket, addressing the reply to the sender. So here this server reads each line from which is sent by the client, and it writes the line back to socket. That means it sends the line back to the client. So for that reason it is called server, echo server. Okay. So there is no connection involved in it. Is possible for the server to interact with the different clients in successive iterations, resulting in interleaved concurrent service sessions. So being connectionless echo server, there is no connection involved. So it is possible for the server to interact with the different clients in successive iterations, resulting in interleaved concurrent service sessions. Okay. So what is that? Interleaved concurrent service sessions. See the sequence diagram illustrating two interleaved sessions with the echo server 1. See, we have two clients here, echo client 1A, echo client 1B, and echo server 1. So echo client 1 sends a message to server 1, echo server. Echo client sends message to echo server, and echo server sends echo reply to echo client. And now the echo client B sends message to echo server 1, and it gets an echo as reply from echo server. Okay. So now again client A, echo client A sends message to echo server, and it gets echo from server, and again the client A sends message to server and gets echo from server, and now client B sends message to server, and it gets echo from the server. So it is called interleaved sessions, because that means the server can provide its service to multiple clients, okay, concurrently. So now connection oriented echo client server. So here in connection oriented, there is a specific connection. Okay, using that connection all the messages will be sent. So messages will be sent using that connection. See here, the echo server 2 will not allow interleaved sessions. See client 1. The client 1, first client 1 establishes a connection with the echo server 2 and sends its message. First it sends message to say echo server and it gets echo. Again it sends message to echo server and it gets echo. Again it sends one more message to echo server and gets echo. So now it closes the connection. Client 1 closes the connection with the echo server 2. Now client 2 establishes a connection with echo server 2 and sends message and gets echo, and again sends message and gets echo. Okay. So here this is connection oriented echo client server, which will not allow interleaved sessions, and connectionless echo server or echo client server, it will allow interleaved sessions. So now iterative server and concurrent server. So there is no overlapping of client sessions, since the server is limited to exchange data with the client whose connection it has accepted. Such a server is said to be an iterative server, since it receives its service as one client at a time. Okay. See the iterative server, there is no overlapping of client sessions, and it services only one client at a time. So iterative server. When requesting service from a popular iterative server, a client will be blocked until all preceding clients have been served. Okay, because it serves only one client at a time, so all other clients will be blocked. The result can be a significant blocking time if the service sessions are lengthy, such as in the case of file transfer protocol. Okay. So, the solution to this problem is to introduce concurrency to the server, resulting in a concurrent server. A concurrent server is capable of conducting multiple client sessions in a parallel. A concurrent server can be provided using threads. Okay. So, thread is a child process or lightweight process. See, the iterative server, it serves only one client at a time. There is no overlapping of client sessions. So then, it serves only one client at a time. So the other clients will be blocked. So to address this problem, we have the concurrent server, which is capable of conducting multiple client sessions in a parallel. So now stateful servers. Both the daytime protocol, it simply provides a daytime, that means day, time and of the specific time. Okay, both daytime protocol and echo protocol belong in a category of protocols known as stateless protocols, as opposed to stateful protocols. A protocol is stateless if no state information needs to be maintained by the server. Okay, in stateless protocol, the server will not maintain any state information. Such is the case with the daytime protocol, where the server just sends a timestamp obtained from the system to each client. Okay, daytime protocol, it just sends a timestamp. And also with the echo protocol, where the protocol only requires that the server echo each message it receives. The server will echo each message it receives. So this is echo protocol, and daytime protocol, it sends a timestamp. So the stateless server is one that provides the service according to a stateless protocol and hence does not have to maintain any state information. A stateful server, as the name implies, is one that must maintain some state information in order to provide its service. So stateless server, it does not maintain any state information, and stateful server, it maintains the information, state information. So there are two types, global state information and session state information. First one is global state information. This type of information is maintained by the server for all the clients throughout the lifetime of a server. For example, suppose a protocol which we will call the counter protocol. Okay, for example, the counter protocol requires that the server maintain a counter initialized to 0. So initially the counter is set to 0. Each time the server is contacted by a client, it increments the counter by 1 and sends the current value of the counter to the client. Okay, so here the counter protocol, a server maintains a counter protocol. So each time a client contacts the server, it increments its counter by 1 and sends the current value of the counter to the client. So to provide such a service, the server must have the value of the counter placed in a storage where it can be retrieved and updated throughout the execution of the server. So the counter should be placed in a storage. So for simple counter, the storage may be implemented using variable or primitive data type. Okay, so here we can use variable or any primitive data type or array or anything to store this the value, that means the counter value. But for more complex state information, the storage may be implemented using a file or a database or any other mechanism. Okay, for complex state information, we will have to use file or database or any other mechanism to store the counter value. Okay, so this is global state information. So now session state information. For some protocols or applications, there is a need to maintain information specific to a client session. See, specific to a client session consider a network service such as FTP. A file is typically transferred to blocks requiring several rounds of data exchanges to complete the file transfer. The state information of each session includes. See, in FTP, the file is transferred as blocks. Okay. So here it requires several rounds of data exchanges to complete the file transfer. The state information of each session includes the name of the file being used, okay, the file name, the current block number, the action being performed on the file, the actions like get, put, etc. Okay, so these are all the information, state information. The session state information, it includes file name or current block number or the action like get or put. Okay, the session state information. Session is an interaction. Okay, so now there are at least two schemes to maintain the session state data. That is a stateless server and stateful server. Session state data. See, the stateless server, in one scheme the session state information may be maintained by the client so that each request contains the session state information, allowing the server to service each request in accordance with the state data sent in the request. The dialog during the session will be then proceed roughly as follows. So see, the dialog will be like this. The session state information may be maintained by client. See, stateless server. So here server will not maintain any state information. Here the state information is maintained by the client. Okay, not by server. By the state information is maintained by the client in a stateless server. See, the dialogues will be like this. Client, please send me block 1 of the file foo in directory some directory. Okay, so server, okay, here is the block of the file. Client, please send me block 2 of the file foo in directory some directory. Server, okay, here is the block of the file. Client, please send me block n of the file foo in directory some directory. See, in this dialog, the client maintains the state information like block 1 or file name or directory name like that, but server, it maintains no information. By requiring the client to maintain the session data, this scheme allows the server to process each request in the same manner and thereby reduces the complexity of its application logic. Such a server is known as stateless server. Okay, in stateless server, server maintains no state information, but the client maintains all state information. But now the stateful server, in the second scheme, the session state information may be maintained by the server, in which case the dialog during the session may proceed roughly as follows. See, in stateful server, the server will maintain the state information will be maintained by the server. See, the dialog will be like this. Client, please send me the file foo in directory some directory. Server, okay, here is block 0 of the file foo, and client got it. Server, okay, here is block 1 of the file foo. Client got it. Server, okay, so here is block 2 of file foo. Client got it. Okay, see, the server is maintaining all the state information like the block number, file name and directory name. Okay, with this scheme, the server keeps track of the progress of the session by maintaining the session state. Such a server is known as stateful server. Stateful servers are more complex to design and implement. In addition to the logic required for maintaining state data, provisions must be made to safeguard the state information in the event that a session is disrupted. If a stateful server host fails temporarily in the midst of a session, it is important for the ongoing session to resume in the correct state. Okay, if at all the host fails, the server host fails, then it is important to resume the process where actually it was stopped. Okay, so it is important for the ongoing session to resume in its correct state. Otherwise, it is possible for the client to receive the wrong block of the file after the session recovers from the failure. Okay. Another example of stateful server is one for a shopping cart application. Each session must maintain state data that keeps track of the identity of the shopper and the cumulative contents of the shopping cart. Okay, so each time the shopper visits the shopping cart, it should be tracked. See, this diagram shows the difference between stateless server and stateful server. See, the first one, the stateful server. Here we have FTP server, FTP client, file ID, file position. Okay. Stateful server, because file ID and file position is maintained by FTP, the server, and FTP client. FTP client sends get file name, and FTP server replies ready, and FTP client asks for send next block, data from block 0 of file is reached the client, and the client sends request for send next block and data from block 1 of file. See here, the block 0 of file, block 1 of file, all the state information is maintained by the FTP server, okay, being a stateful server. And stateless server, here FTP server maintains nothing and FTP client maintains file ID and file position. See, get file name, FTP client sends a message get file name and FTP server sends file ID, and FTP client send file ID block 0 and data from block 0 of file, and FTP client send file ID and block 1 data from block 1 of file. So here all the state information is maintained by FTP client. Okay.